This testing video for the machine learning project. This project is basically to do with loan repayment and predicting the probability of a person to default in paying a loan, and that's a classification problem, and there's also a regression problem, which is predicting the repayment latency. So as you can see here, we have 5 files. We've divided the program into 5 files. There's main, models, interface helpers, and configurations. So let's go and run the program then. Here we go. Over here, as you can see, you have a classification option and a regression option, and you have different parameters. You have, first of all, the regularization parameter, which is going to basically control how strongly the kernel SVM is going to penalize mistakes for the classification. So if it's larger, there's more chance of overfitting, and it will make the model fit the training data more strictly. And here you have kernel influence, so either you can scale it, or you can go auto, or you can put a fixed number. What this is basically going to do is control how much influence each training point has in the kernel, and it will affect how smooth the boundaries are going to be, the decision boundaries in the end as well. And so naturally, if you have a larger regularization parameter, it will mean that point has a greater influence. Finally, as our classes were imbalanced, we have the option to the user to balance the classes as the default or choose not to balance them. Here you have a random seed as well to be able to reproduce the result, and you have a split size. The split size is to do with basically when certain metrics are given, what part of it is going to be used for the training and what part will be used for the testing. And we have a regression option here. For the regression, we're not using for the classification, we're using a kernel SVM. For the regression, we're using a decision tree. And you have here the option of a tree depth limit and the minimum records per leaf as well. So let's go and enter some files. We have an option here to enter an example file. So we can go here, we can press browse. And over here, straight away, you have the QuAM test files. We have different testing files for the purpose of this testing that we've made: small, medium, large, balanced, and so on. So for this one, we will go for the medium. And the difference between the query and the training datasets is essentially that the query datasets do not have the labels, and the training datasets have the labels. And so it's kind of simulating the real world aspect. So let's go with, first of all, the training dataset. We'll put the medium size one, and we can go ahead and load it. Now for the unlabeled query dataset, for example, we have a bunch of customers now, we have their data. Now we want to, after training on this larger dataset, we're going to take the smaller dataset and we're going to try and query results on it. So we went for medium on that one, so it only makes sense to go for medium again here for the query dataset. And as you can see, it's loaded. If you do enter an already labeled dataset, that's fine. But and if you don't enter a query dataset as well, it will just automatically take the training one. However, to simulate the real life application, you would have an unlabeled dataset for the query. So over here now, we've uploaded both of our files. Classification, here we have some parameters. We'll leave them as they are for now. And we can train the model. And now as soon as we train the model, based on the evaluation split size we have here, we have certain metrics already we have done through validation: accuracy, precision, recall, and F1 score. And because this is a classification for the probability of the customers defaulting, this is the first 10 rows, the probability of the customer defaulting. And we can now inference any customer. So let's go inference customer number 17, for example. 17 has a very low chance of defaulting. Actually, that's 0.0087 probability. Because most customers are likely to be non-delinquent and not default on their loans, we have an option for the institution to go ahead and straight away locate all the predicted delinquencies. So over here in this data set, we have 3 customers which are predicted. To be predicted to have a delinquency essentially will mean that the probability is larger than 0.5. So as you can see, we have these 3 customers that are predicted right now. Now let's go ahead and practice the regression one. Let's test it out. For regression, again, we have some parameters here. We can change it around. We'll keep a tree depth limit of 4 on this occasion. And we can use the same data sets as well, because they have columns for the repayment, to do with the repayment latency as well. Now we can train the model. First of all, as you can see, we have a target as repayment months, 1,500 rows, and because of this evaluation split size, 1,200 have been used for training and 300 for testing in order to come up with these regression metrics. As you can see, the R squared is pretty good, 0.998. Now let's go ahead and predict a certain customer. Let's go predict the same customer, number 17. As we can see over here, the customer number 17 from the inference dataset has been predicted that they are going to repay their loan after a latency of 6 months. Now we can go and put a different number as well, 25. Over here, again, 6 months. And 31, 60 months. Now this customer has a repayment latency of 5 years. So as you can see, the software is quite sophisticated and tailored to the purpose of a financial institution. And there's a lot of error handling as well. For example, I cannot add a minimum records per leaf, for example. If I was to try and train the model, as you can see, minimum records per leaf must be at least 1. And there are different error handling we've already done as well. So this is our program. We have, just to recap, a regression problem to predict the latency of the customer repaying the loan, and we have a classification problem which is probabilistic to predict the probability of a customer to repay the loan that they have requested. Thank you very much.